Hello everyone, welcome you all to this new video where we are continuing with the concepts of module 1. So in this video we are going to discuss the discrete time signals and system representation. Okay, how the signals and systems are represented in a waveform. Functional representation of a discrete time signal, that is one function would be given, and for that the values of samples would be varying with respect to the values of change in n. Okay, so this is in this way the functional representation is taking place. Sequence representation, like this, okay, it would be representing like this, as we have seen in the further modules, okay, of module 3, 4, 5, which is done, how a sequence is represented. So for a discrete time signal, this is the sequential representation, where this arrow mark indicates the zeroth term, okay, where the value of n is 0. Wherever it is 0, that arrow mark is indicated. Okay. Yeah. Some elementary discrete time signals. Now let us see some of the elementary discrete time signals now. First is unit sample sequence or unit impulse response. Okay. What is the definition? It is denoted by delta of n. Okay, that you might be knowing. And it according to its definition, the value of delta of n is 1 for all the values of n greater than 0, and value of delta n is 1 for n equal to 0, and the value of delta n is 0 for all the values of n which is not equal to 0. Okay. This next is one is unit sample sequence. Next is unit step sequence, and it is denoted by u of n, and it is defined as u of n is equal to 1 for all the values of n greater than or equal to 0. It's not mentioned here. I'm telling you, for all the values of n greater than or equal to 0, it is 1, and it is less than 0 for all the values of n less than 0, it is 0. Okay, so in this way the unit step signal is represented. Next is unit ramp signal. It is represented by u r of n, where the value is n for all the values of n, and it is 0 for all the values of n less than 0. Okay, and this is the exponential signal, that is x of n is represented as a power n. So let us see its graph now. So this is the graphical representation of a unit sample signal, that is at n equal to 0, the value is 1, and at n not equal to 0, that is you can see here, except n equal to 0, for all the values it is 0. Okay, so this is the basic unit sample signal, and this is the unit step signal. As I've told you, for all the values of n greater than or equal to 0, it is 1, and for all the values of n less than 0, it is 0. Okay, next is a unit ramp signal. As I have told you, for u of n is equal to u r of n is equal to n. That is, if the value of n is 0, the value is 0. If the value of n is 1, it is 1. For 2, it is 2. For 3, it is 3. 4, 4 goes on. Okay. If you join this line, you can see that a ramp signal is produced. Okay. For all the values of n, the ramp signal definition is it is by itself. Okay. If the value of n is 0, then it is 0. For 1, it is 1. Goes. Next is a exponential signal, where this is the values of where the negative amplitude, where the amplitude is decreasing here, and here the amplitude is increasing. Okay, graphical representation of exponential signals. Next is classification of a discrete time signal, where a discrete time signal is classified into energy signals, where energy of a signal is defined by uh, we have the formula for that, which we have discussed in the model paper solutions. Okay, you can note it down. Okay, here it's not mentioned here. Energy and power signals. Okay, both of them we have discussed in the model paper solution part, so I'm not going to discuss that in detail. Okay, so I've already discussed the formulas in the model paper solution. So if you're not satisfied by these videos, you can go and refer the model paper solutions, where we have discussed different kinds of problems related to module 1. Okay, next is periodic versus aperiodic signal. You can go through it. Discrete time systems. Okay, again, this is we have discussed it in the model paper part. So in this way, the systems are represented. So yeah, that's all, guys. That's all for this video. So if you want some more stuffs of module 1 from model paper solutions, from module 1, I've discussed around 6 problems, 6 different kinds of problems, where we have seen the signals, and we have seen some of the problems of this module. So you can go and refer that. It is available in my channel. I've already left it in my channel. It is there. So please go and watch it. Okay. So that's all for this session, guys. Thanks for listening.